Why don't you guys go to page 2 of the notes for 3.4? So was the formula that was different? Was it the arc secant and arc cosecant formulas that were different between AP Classroom and formula sheets? Did the AP Classroom one just not have the absolute value symbol?
It didn't have that. Instead of a square, instead of the X under the. Oh, it didn't have. It was like 1 over. It was just square. Oh wait, we don't need to know that.
It was under the root symbol?
Yeah, like a 1 over X squared under the root symbol.
Okay, so absolute value of x is the same thing as square root of x squared. And so it's possible any formula you have is going to be fine. So if a formula is printed in a textbook somewhere, it will be accepted and allowed. However, it won't matter because you will only ever be asked on the AP test to do the derivative of arc sine, arc cosine, and arc tangent. You won't ever be asked to do the other 3. So I have seen other formula sheets that didn't have the absolute value symbol there. It just had like an X. And so there's different versions of kind of the same formulas, but they're pretty much traditionally just the bottom 2 there, which won't matter because you won't be asked to do that. So
on the AP Classroom one, it had 1 over. No, I was gonna say. On the AP Classroom formula, it had like 1 over square root 1 minus u squared for arc sine instead of y prime on top, or u prime on top.
oh, that's because the one in AP Classroom just had an X, didn't it? Did the formula from AP Classroom have X's instead of U's?
No, it had u.
And it
It
didn't,
just had a 1 on the top, like, you know, very.
did it have times U prime at the end?
Yeah. Oh, yeah.
Okay.
Times
So,
two, yeah.
yeah, they're the same formula. So if it has a 1 on the top, but a U prime multiplied at the very end, it'll be equivalent. This one is just basically all in one fraction. Every single different source, for whatever reason, likes to write the formulas their own way, so if you already have them written down somewhere, you don't need to write them down again. I just put this up here for anybody who needed to write them down that hasn't written anything down yet. So there might be some homework questions, but I'm not asking you to do the homework from the packet. Your homework from 3.3 and 3.4 was just an AP Classroom. So you don't necessarily need to do this homework, but if you wanted to do the homework from 3.3 and 3.4 as a method of studying for the test, you're welcome to. I can, you know what I'll do is I will just put the answer keys to the homework and the 3.3 to 3.5 review. I'll just put the answer keys in the folder for Unit 3. So then that way you guys can have a chance to look them over this weekend while you're studying or getting ready. But I thought I would do some of these questions with you guys just so you're used to doing it. And I'm sure you might have already done them, and if you already feel comfortable with these, that's fine. Just can't hurt to do some problems together. I don't know if we'll have a ton of extra time at the end of the hour, but if we do, you're welcome to use that to ask any kind of questions from the 3.3 to 3.5 review, or show me any kind of homework that you want to turn in, whatever. You don't have to show me anything from AP Classroom, by the way, because I can just look that up. Does anybody need this up there yet? If you do, then just say yes. You don't need to feel embarrassed about this.
You have the sheet?
No.
Not yet. You said you give me a paper.
Yeah, I know. I forgot.
It's all good.
That is a super common thing. What I can do is I can print it at the end of the hour and just have you go and run and pick it up in the library or something. But yes, these should be on that formula sheet as well. Okay, to be honest, I pretty much put these on here for me, so that when we're doing the problems, I can scroll and look at the formula. I do not have these memorized. These are something that are kind of, I don't want to say temporary memorization, but it's frequently what happens. Okay, so it says let y equal inverse sine 3x. And I'm assuming by now you guys know that arc sine and sine to the -1 are the same. Hopefully, yes. Okay. So, because I see the formula there is written as arc sine, but this one says sine -1. All right, so let me write down the generic formula first, and then we will go from there. So the generic formula for inverse sine, where am I reading this? U prime over square root of 1 minus u squared. And this is when the original function is arc sine of u. Okay, so we essentially just need to figure out what u is to write it in the formula. And that is going to go to, I know you love this thing, Elise. What would the u be for question number 1?
Isn't it 3x?
It is. It's basically just whatever is written, where's blue? It's whatever's written in this parentheses. So 3x is the u. So our derivative is going to be square root of 1 minus, and then make sure you put the 3x in parentheses, because then when you square it, it would be 9x squared. I don't know if you want to just answer this one really quick, Elise. What would u prime be?
3.
Correct. Perfect. Okay, I'm okay if you leave it like that. If you want to write it as 9x squared, sure. But the one thing I want to make sure you don't do is you cannot do the square root of 3x squared. Because this subtraction symbol right there means that you cannot do the square root of them separately. So over the years, that's the biggest mistake I've seen, is people forgetting that the square root of things being multiplied. So like if we had square root of a squared times b squared, you can do these individually because they're multiplied. So like, I guess technically this would be absolute value, but we'll pretend that's not it. You can do those individually, but this one you cannot because of the subtraction. So you have to leave the answer as that. This is honestly why I kind of like doing the derivative of arc trig ones, because there's really not anything to do other than to fill in the u value. And then that's it. You don't necessarily have to do a lot of thinking. Okay, should I skip number 2 since it's pretty much the same thing, or do you want to do number 2 together?
Do number 2 on our own.
On your own. Okay, go for it. How come they got louder when they walked by? Yeah. Sometimes things can cancel or reduce, just not on this one. Basically, you just had to figure out that 4x squared was the u value. And so you would put that in parentheses squared, and then the u prime would be 8x. Now, if it asked you to find the slope at an x value, then you would put the x value in there, and that's pretty much it. Okay, so I saw 3 and 4 when I looked at these questions, and I was kind of interested in number 3. I thought that would be a good question. Did you guys look at number 3 already? No. Okay, take a second, look at it, maybe try to figure out what to do in your head first. We'll do it together, but maybe just try to figure out what you might have to go about.
Yeah, to get it to, yeah, just divide by E. You don't divide by E.
Cannot divide by
You
E.
don't divide by E. It's like E to the.
Okay,
Multiply by E.
2 methods you can do, both work. One, you can do implicit differentiation and just do the derivative of everything that's up there. 2, you could solve for y first and then just do regular derivatives. Both work. Do you guys have what did you guys, the reason I wanted you to look at it first is I was wondering what you guys initially thought of doing. I feel like I heard some people over here solving for y. Okay? Is that what most of you tried to do? Okay, I'll do it that way. Implicit absolutely works as well though, by the way. So we'll solve for y. So we've got arc sine of x equals ln y. How did they teach you guys to solve for natural logs in pre-calc? I know when I taught pre-calc forever ago, I taught people to take it out of logarithm form, but I don't know how I don't know how they taught it last year. That's what they taught? Is that what Miss Larson did, was have you take it out of logarithmic form? Okay. Well, so ln of y technically means log base e of y. And so if you take it out of logarithmic form, it would be e to the power of arc sine of x. That's why you can't divide by e. Equals y. I think for some of you, you might have had an easier time doing this implicitly, to be honest. But it doesn't matter. So this one is actually pretty easy to do the derivative of, other than it just looks weird. So the derivative of e to any power is you rewrite the exact same thing and then multiply by the derivative of the power. So the chain rule would be the derivative of arc sine of x. Arc sine of x, u prime over square root of 1 minus u squared. The u in this case is just an x, so it's fairly straightforward and simple. So I would say square root of 1 minus x squared on the bottom. The top would be the derivative of x, which would be the 1. There really is no simplifying this. If it was simplified, I guess theoretically you could write e to the arc sine of x on the numerator, and then the denominator be square root of 1 minus x squared. But it's not simpler, it's just different. Do you guys want me to do it implicitly to show you the other way? Okay. So we'll pretend none of this happened. Implicitly, I would do the derivative of arc sine of x on the left, which we already wrote down once. And then on the right would be the derivative of natural log of y. The derivative of natural log of anything is 1 over that item times the derivative of that item, which would be y prime. And so then we would just multiply both sides by y, and that would be the derivative. They're equivalent, even though they look totally different. So if you had either one of those two answers, you're good. Because if I wanted to solve for y in the beginning, it was e to the power of arc sine of x. So it would have been equivalent answers. This is just much quicker, in my opinion. I know you guys aren't super comfortable with implicit yet, but it generally saves time depending on the setup of the problem. Okay, should we do 4 together? Do you want to try 4 on your own? No, oh, okay. Find the equation of the line tangent to y equals arc sine of x at x equals root 3 over 2. We should probably call on somebody. Luke. Okay, what's your first thought on finding a tangent line? What do we do first? There's a couple different things we need, or should I just ask you what are the 2 things we need for a tangent line?
Point and slope.
Point and the slope, okay?
Take the x, plug that in the original equation.
You can do that first if you would like. Take the x value, plug it in the original equation to find the y value.
And then do that same thing with the derivative.
Okay, so square root of 3 over 2 is the x value. Arc sine of square root of 3 over 2. That means I need to find, sine has 2 primary quadrants. Like if you're using a calculator, quadrant 1 is the primary quadrant for sine, cosine, and tangent. Quadrant 2 is the negative quadrant for cosine. Quadrant 4 is the negative quadrant for sine and tangent. It's kind of annoying. They're like arc trig ones are strange. Okay, so this is positive, so it really doesn't matter. I'm going to be looking in quadrant 1. I want to figure out which triangle has an opposite side of square root of 3, a hypotenuse of 2. And so this is the 1 to 2 to square root of 3 triangle. The 1 is always across from the 30-degree angle. Square root of, that's a terrible 30. Square root of 3 is always across from the 60-degree angle. So arc sine of square root of 3 over 2 would be 60 degrees or pi thirds. I know in calc they pretty much pretend that degrees never isn't a thing. Everything's in radians. But I think most of you probably think in degrees in your head. There's nothing wrong with that. Okay, so there's the point. That was not a minor thing. That was probably the most work for you in the problem. Winston, you can pretty much get chosen every day. Okay. I'm not going to argue with it. How do we go next? Like, how do we find the slope? Because we found the point.
You find the derivative of that.
Okay, what's the derivative of arc sine?
It's 1 over square root of 1 minus x squared.
Okay, and then the derivative of x was at the top, but that's 1, which is correct. Okay, what do I do with that?
You plug the square root of 3.
Perfect. And this might come out terrible, I don't know. 1 over square root 1 minus square root of 3 over 2 squared. Okay. Square root of 3 over 2 squared is going to be 3/4. So 1 over square root 1 minus 3/4 would be 1 over square root of 1/4. Winston, do you want to keep going or do you want to pick somebody? Or should I roll?
Row.
Okay. I know I did a bunch of that algebra, but I thought Arjun could tell me what's 1 over square root of 1/4 without a calculator. It is not 1/2, but that is awfully close. It is going to be 1 over 1/2.
Oh wait, the final answer is 2.
Correct. Good. You were just answering square root of 1/4 out loud. Yep. Okay, good. So slope is 2. I absolutely don't have enough room to work here, but we're just going to make it work. I'm just gonna keep erasing, I guess. And now the important question that we get asked about a million times throughout the course of the year. How to write the equation of a tangent line. You should have it down pretty much automatic by now. Charlie, not here. Ooh, Rowan, that was so close. Oh, did you want to go? Oh, okay. All right, Rowan. Failing out Charlie.
Y minus 5/3
Perfect.
equals 2 times x minus
Yep.
3 over 2.
Nice. All right, nice job. Tangent lines, that's pretty much how they want them consistently throughout the year. If you want to write plus pi thirds at the end, you can. AP allows all the different versions of it. Okay, 5, I didn't feel like we needed to do because the only difference is that it's a cosine instead of a sine. Okay. Actually, we have a decent amount of time left. Is there any problems that you would like me to help you with from anything you've been working on? I don't know if you have them written down somewhere. I can certainly just do them up here if you would like. John, are you trying to say yes, or are you just stretching like mad over there? Okay. You look like you were super interested in answering. Oh, second derivative?
Well, Isaac was here and he saw him hit me in the head. He'd started.
Problem set D, number 3.
He's going. If someone slaps you,
Oh, okay.
he's gonna charge at you. It was from across the hall. Assuming that he's running over the tree.
I wasn't ignoring you. Yep. Okay, perfect. Let's go with, oh. This is problem set D, number 3. This was from the review, 3.3 to 3.5. This is the 4th page, 3rd problem. Hunch. I guess my question to you is, do you remember what the formula is for derivative of an inverse?
Yeah, it's 1 over f prime.
Whoa, wait, you're too fast for me. 1 over f prime
And then
f inverse of x. So on this particular problem, instead of writing f inverse, we're told that j is the inverse of h. So I'm just going to write j of x. So j represents the inverse of the problem that was listed at the top most likely. I think h is up at the top, right? Yep. So say it again. We haven't done anything, so I don't know. That's a good question. Okay, so h is arcsine of 1/4 x. So j of pi thirds, j is h inverse. So j of pi thirds, we want to figure out what that is. And that means h of this imaginary number would have pi thirds as an answer. That's how they would be inverse. So I need to find out, when is arcsine of 1/4 x equal to pi thirds? Okay, that's actually, so I'm going, since it's positive pi thirds, I'm going to draw a triangle in quadrant 1. pi. Oh, wait. Why is this messing with my brain? Pi thirds is the angle. So that's 60 degrees. So the sine, arc sine of, yeah, that's right, because when you're doing arc trig, you're going to do arc trig of a ratio, and then the answer would be an angle, because it's backwards from normal. Normally, we do trig functions of an angle, and the answer is a ratio. But because our equation is arc sine, it's reversed. So pi thirds is the angle we're dealing with. We want to know the correct ratio, which would be square root of 3 out of 2. What makes this even worse and weirder is that this equals square root of 3 over 2. Because this parentheses is the ratio that we're looking for, so we'd have to set the parentheses equal to the ratio. So x is going to be 4 root 3 over 2, which would be 2 root 3. I don't know if I lost you on that step or not. Yeah? Re-explain it?
Maybe a couple before.
Let's start with this. Are we okay with what I wrote in the black box? Okay, because that means they are inverted. Yeah, and our whole goal is to find out what j of pi thirds is. And to find j of pi thirds, we have to figure out when h is equal to pi thirds. So arc sine of 1/4 x is going to be equal to pi thirds. So I drew a triangle at pi thirds. And the sine ratio from pi thirds is square root of 3 over 2. What makes it weirder, that thing equals square root of 3 over 2. Because if I write down inverse sine of square root of 3 over 2, the answer would be pi thirds. But square root of 3 over 2 is written as 1/4 x. And so I have to figure out when 1/4 x is the same as square root of 3 over 2. So I did like a little tiny equation above it to figure that out. And that's how I got 2 root 3. So I'm trying not to do every step in my head at once, because that's absolutely going to break your brain. If you try to do all of it at once, it just doesn't work. So you have to kind of compartmentalize and do little bits at a time. So that's what I was trying to explain out loud when I was going along, is I'm figuring out little bits along the way. So at this stage, I've gotten to the point where I found out x is 2 root 3. And so 2 root 3 is the question mark that I'm going to write in place of j of x, or j of pi thirds. That clearly is going to be the worst part of the problem. Okay, and I can pretty much erase all this now, because all of this was just for the inverse information. Now in my formula, I've got it set up to do 1 over f prime of 2 root 3. I wrote f prime, but I should have written h prime, because there is no f in this problem. I should have written h prime. So I need to find h prime. What was it again? Arc sine 1/4 x. So the derivative of arcsine is u prime over square root 1 minus u squared. I can simplify that and do stuff with it if I want, but I mean, I'm not going to because I'm going to be plugging a number in. So 1/4 over square root 1 minus 1/4 times 2 root 3, which is square root of 3 over 2. Actually, this is the exact same problem we just did right before, wasn't it? Except for the 1/4 on the top. So the square root on the bottom is going to equal 1/2. So I've got 1/4 divided by 1/2, which would give me an answer of 1/2. So 1 over 1/2. And hopefully the answer key says the answer's 2. Oh, I didn't give you guys the answer key, did I? No. Should we look it up? I don't know if I'm going to regret this, but we're going to look it up. It's always a little nerve-wracking getting to the end of a long problem, finding out if, like, there's so many chances to make a tiny mistake along the way. What did we do? 3? All right. It's 2. I will attach this. I'll put this answer key in the folder for you guys so you can look things up too. Phoebe, are we okay with that one? Shaky?
How did the bottom become like root 3 over 2?
Right here?
Yeah.
So I needed to plug in 2 root 3 in place of x. And where is it? The u, I'm pointing to my screen like you can see it. 1/4 x is where I'm substituting the x. So 1/4 of 2 root 3.
Oh.
And that's root 3 over 2. Anybody else have a different question they want me to help with or anything? Otherwise, I mean, like, I can certainly just shut off the computer and give you 20-ish minutes to work and come ask questions if you'd like that too. So the test is Monday. I'm going to focus mainly on 3334. I will let you guys know that the next unit is basically about 2 weeks long. We are not going to try to rush it to fit it in before break. It would be so much better, and I would like to, but I'm also not going to like push you to the break of breaking. So we are going to be taking the test the first week we come back, which stinks, and I'd rather not, but it's going to be better for us. So we'll make sure to review when we come back from break before the test and everything, but just letting you guys know it might feel like everything's going really fast right now to you, but we are not like going overly fast just to fit things in. So we'll take this test on Monday. You'll have 2 weeks to be able to retake it before break so that you don't have anything to worry about over break other than prepping for the next test. Okay.